Good morning. Today we'll be covering some past paper questions on the chapter of enzymes. There are 30 questions in total. Now, in the first question, as you can see that they have combined reactants and products with the help of an enzyme and either made the products or either broken them down. So now, as you can see over here, they have combined X plus E to make a combination of X and E. Over here, in this third reaction, you can see X, Y, and E are broken down to form Z and E, and X has been eliminated. So they say, what is the fourth and final reaction? If we analyze all the four available options, we can easily see that in option A, there is X plus Y plus E gives you C, give you Z. That cannot happen. Obviously, if they were to combine X, Y, and E should be in the product cumulatively. Similar in the case is the cases with options B and C. However, if you closely look at option D, you see that in the reactant side there are only Z and E, and in the product side Z and E have been respectively broken down. Now, if we come to question two, first you need to know that salivary amylase solution has the optimum pH of 7. So it likes neutral pH. That is useful information for the future. So now, if we stick to this question, we need to know biuret solution is used to test for proteins, iodine solution is used to test for starch, and Benedict solution is used to test for reducing sugars. Now we also need to know the color changes. Biuret solution turns purple when it's positive. Iodine solution turns blue black when it's positive, and binary solution turns red when it's positive. So what is amylase do? Amylase converts starch into maltose. So obviously, and amylase is a carbohydrate. So iodine will be positive. However, since amylase is a carbohydrate, thus neither biuret nor thus biuret will be blue, whereas Benedict will be blue at its testing for glucose. Therefore, there are no proteins in this solution. Now, if we come to question three, they Gaines asked which is the largest area without starch. As I discussed previously as well, that amylase exists in a neutral pH. So in option B, by adding hydrochloric acid, the pH will be turned acidic and thus the amylase will not be able to work. Similar is the case with C. In the case of C, protease enzyme breaks down proteins, not carbohydrates. And in obviously D contains protease, so it has been eliminated. So the best available option is option A. Now they say, what is in question 4? What is the distinguishing feature of or adaptation of these organisms? You need to know that they've told us that these organisms reside in areas which are very dark, so obviously they do not carry out the process of photosynthesis. And if they don't carry out photosynthesis, they don't need to be green and don't need to have chlorophyll in them. Now in question number 5, this basically have asked for the enzyme protease. You need to know that protease or pepsin are the same, and its optimum pH is pH 2 or the acidic pH. So the option C is the best among all of these options, because in option C you can see the digested or egg white or protein is maximum in acidic pH, and it decreases as the pH goes on increasing towards pH 14. In other options, there is a mismatch. As you can see, there's an increase. However, the decrease is not proportionate, and there's again an increase in alkaline pH. Now, in question 6, they are saying that which is the reaction in which both enzyme and substrate can denature. We know that all proteins can denature at high temperature. So what does protease do? Protease breaks down proteins into amino acids. So in this case, both the substrates and the products are proteins in nature. Therefore, both can be denatured. Now, according to in question 7, they asked for the substrate of the relevant enzyme. According to the lock and key model, we know that every enzyme has a corresponding shape with its substrate, which is the key. So obviously the key must exactly fit in. And if we closely look at the all the shapes, molecule A has the same symmetry which the enzyme has. Now, if we come to question number 8, they've said the optimum temperature of bacteria is 75 to 85 degree. So their maximum activity in all these graphs should be lying between around 75 to 85. And after that, it should suddenly decrease because of denaturation. So option D is the best fit. In question number 9, they say that an enzyme works best at pH 7. What will be its shape at pH 13? You need to know that the enzyme will be denatured at this pH. However, the critical concept is that the substrate will not be denatured at this pH, and this occurs. So in all these options, if you can see that we need to note that the substrate will be of the exact same shape. So if you closely look at these options, only A and in only option A and C, the substrate has the same shape. And in option A, the enzyme is exactly like it hasn't been denatured. So option C is the correct answer. Now in question number 10, they asked that the molecule has changed shape. Now in the molecule changes shape in either extreme cold temperatures or in extreme heat temperatures. So option is A. In question number 11, they asked the properties which are correct for all enzymes. Of they are for all proteins, we know they help to speed up at the chemical reactions. So options 1 and A3 are correct. Why and 2 and 4 correct? Because they are saying for all enzymes. We know that there are enzymes even in the oral cavity. There are enzymes secreted everywhere in the endocrine system, and none of them work at low pH. However, we know that there are many enzymes which work at low pH. We just talked about pepsin, which breaks down proteins. Now, in the lock and key model, we know that the active site is always on the enzyme, and the key is always the substrate, and the active site is also known as the lock. So, option is A. In question 13, again lock and key. Lock is the enzyme, and the enzyme is amylase, and the lock and key. So the correct option, and the key is the substrate. So amylase should be the lock. Where is it? Oh, yeah, it's C. So the key is the substrate because the substrate fits onto the lock and it breaks down, amylase breaks it down into maltose. In question 14, lipase is the lock, whereas because in lipase is the enzyme. So option is D. In question number 15, they say that in which beaker will the color change occur? We know that the optimum temperature is closer to 40 degrees. So the beaker which has the closest temperature to 40 degree will be 35 degree, and after there won't be so much color change in the rest of the beakers, and not even in 90 degree there won't be a slightest color change because of the denature of enzyme. Now I've told you about it previously as well that iodine solution turns blue back in positive in positive. So the correct option will be B, because in 35 degrees it will turn bluish black after 30 minutes. Yeah, now they say that what is in of the above options, which option is the best one, which shows that pepsin is an enzyme. To show that pepsin is an enzyme, we need to show that pepsin denatures at high temperatures. So the correct option is C, 4 and 5, because it shows that without denaturation, it produces large amounts of amino acids. However, when it's been boiled, it produces only traces. Now, question number 17. You need to know that that a normal graph has a optimum temperature of 40 degrees. So always the curve can be like this. However, the problem with it is that it doesn't show any rise in temperature since 0 degrees. However, the option has been correctly, the graph has been correctly shown in option C, in which they show that there has been rise in temperature and sudden drop after 40 degrees. Lock and key again. You need to know that this is an essential concept, and it will be tested repeatedly again and again. Protease, where is the protease log? It's C. However, it's written in B as well. Breaks down proteins into amino acids. So whatever it breaks down, that is always the substrate. So our option is C. What is the best explanation of the results? There are policies, and they ask us to investigate the effects of heat. We all know that heat leads to denaturation, so obviously, answer will lie between A and B. And the best concept which they're asking about is denaturation. So it's correct that amylase is denatured when they are boiled. Again, lock and key. Lock is always the enzyme. Active site is always lies on the enzyme, and the substrate always acts as the key. A is answer. Protease breaks down proteins into amino acids. A is answer. It's pretty simple as we get down. Where is in the digestive system is the enzyme albumin protein. Albumin is a protein, and all proteins are produced in the liver. In question number 23, the same concept of enzyme and optimum pH has been tested. You need to know that pepsin works best in acidic pH. So the best option is will be B because it's at the addition of HCl will lead to an acidic pH. Which statements are correct? Option 1 and 2. Option 1 and 2, chewing increases the surface area and amylase is an enzyme. However, why question number 3 and option 3 and 4 are incorrect? Teeth only breaks it down. It can't break down large insoluble molecules into soluble ones, and saliva cannot do emulsification. This is the property of bile. Bile does the emulsification of fats. Which statement about an enzyme is essential to the lock and key? Yeah. So they are asking about the option which looks onto the shape of the enzyme. Yeah, enzymes are denatured by high temperatures. Denatured by high temperatures, each enzyme molecules. Yeah, so they also have to talk about the substrates. Although all four of these statements are correct. However, you need to know that for the lock and key, the key will only be able to fit in if it has the corresponding exact shape as the enzyme. So option D is correct. 100 degrees. Again, you need to note that the substrate does never changes its shape, whereas only the shape of the enzyme is changed. So this is the original shape of the enzyme and the substrate. So, and in the B, C, and D, you can see that over in B, the substrate fits. So the substrates cannot fit because the enzyme has been denatured. The best option is option C. Biological washing powder contains proteins and fats. So the correct option will be okay. Now, enzyme catalyzed reaction in the alimentary canal varies with temperature. Again, I've repeatedly told you this is the characteristic curve. In question number 29, they ask the correct labels. We know that P is the enzyme, that is since it is the active site lies on it. So P will be the amylase, Q will be the substrate. So Q will be starch, and correspondingly R and S will be broken down into maltose and glucose respectively. A. Question number 30, they ask about amylase. I've done this question above as well. It's been repeated. Amylase, we know that covers the largest area, and neutral pHa will be the answer. And at which molecule will be the most amount of product molecules be released? We know that the most amount of products are released at optimum temperature. 40 is the optimum temperature in humans. So the answer lies C, and the enzymatic activity is greatest over there. Thank you. Hope you like the video.